Here we just have some examples asking for the domain of each of these functions. This is just practicing looking for the domain restrictions. I have the initials off to the side here. The three things we want to look for: F is for the fractions, E is for the even root, can't read any of this, N is for the negative exponent. If we have any of those happening to our x, then we have some sort of a restriction happening. So f of x equals 3x plus 4. Here's the x. Is x in a fraction? No. Is x taking an even, are we taking the even root of x? No. Does x have a negative exponent? No. Since we answered no to all of those, our domain is just all real numbers. We have no restrictions. Our next example, x over x minus 2. First look for, is x in the bottom of a fraction? Well, it is in the bottom of a fraction, so that means that we have a restriction. The bottom of a fraction in mathematics cannot equal 0. So we have to think, all right, x minus 2, this whole denominator, cannot equal 0. So what number can x not be? In your heads, you may be coming up with it, but I can also just do the math for it. I add 2 to both sides, so here I'm showing that x cannot equal 2. So there's one restriction. Now let's just go through the other restrictions just to make sure we don't have any more. Are we taking an even root of x? No. Does x have a negative exponent? No. So our domain is all real numbers, but this one restriction we came up with, x cannot be a 2. I was going to say a negative 2. So x cannot equal 2. X can be any other number, but once x equals a 2, it gives us a 0 in the denominator of a fraction, and mathematically that cannot happen. Alright, so our last example, x squared plus 2x minus 2x plus 1. We look, is x in the bottom of a fraction? No, it's not. Are we taking an even root of x? No, we're not. Does x have a negative exponent? No, it does not. Since there were no restrictions, our domain is just all real numbers, which means we can plug any number in for x. We can plug in negatives, we can plug in 0, and we can plug in positives and be okay on this one. So that domain is all real numbers.